And how do you know it? Determine the power. I mean, it's pretty simple, right? Okay, now, what I'm going to do is I'm going to try to fool you. I'm going to put the word power in a whole bunch of problems, right? It'll be a chapter 12, blah, 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 and the motor happens to have a power of 20 horsepower. And I'm expecting you to see the word power and go, oh, and then start going to the power, and you just messed it up. Okay? Right? Okay, so anyway. Elevator in is rated at a total mass of 400. Hoisting is provided by the motor, blah, blah, blah. If the motor has an efficiency of 0.6, determine the power that must be supplied to the motor when the elevator is hoisted up at a constant speed of 4. Okay, how am I going to find that? Well, I'm going to write down efficiency equals, just like I did before, so efficiency, 0.6, equals what? Power out over power in. Where does the power in come from? From the motor, okay? So that's what I'm trying to find. So what I need to do is I need to find the power out. Where's the power out? It's in the elevator, right? Okay, so what I want to know is I want to know what's the power in that elevator. Right? So here's what I'm going to do. I'm going to say, well, I'll tell you what, whatever that is, it would be the speed of the elevator times the force in that rope. How come I'm not going to worry about C? Why don't I worry about C? It's not, yeah, well, C's got a velocity, but it's not coming from the motor. It has nothing to do with the motor supplying that, right? So what I'm going to do is I'm going to find the velocity of the elevator. Well, they come at the velocity of the elevator. And then I'm going to find the tension in that rope. Right? There's 3 ropes, right? 1, 2, 3 that connect up to the motor. And that tension, 3 of those tensions, times the velocity is the power that's being supplied by the motor. And the elevator's taking it. You see that? So that hanging mass C has nothing to do with anything. It's just there to try to confuse you. And which it did, right? That's what I'm here for. Confusion. No, I mean, to fix the confusion. Okay, so how am I going to find the tension in the elevator? Yeah.
I know it's really light, but what if it was really heavy?
Which one?
C.
Does it matter? Is this energy, this power, this anything here, coming from the motor?
Gravity.
Okay, well then that's, what's the efficiency of gravity? That's a different question. What you want me to do is say, how big a motor do I need? Does make sense? Right, so they want to know how big a motor do you need to lift these fat people up. Hey, and if this thing was heavy, if it was really, really heavy, the motor could be light, couldn't it? This guy right here would be doing a lot of power, sure, right? It's gravity, right? Doing a lot of power, sure, you bet. And that's why this guy can be a light motor, a small motor.
So basically, we're not taking into account the battery because it's already moving.
Well, basically, if I said, what is the energy that you have to have? Okay, I need some energy from here, I need some energy from the motor. But nobody asked me about that guy. Yeah. They just say, like for example, suppose C was exactly the right weight to just lift it up with no problem at all. Do you need a motor? No. Get the idea? You wouldn't need a motor. Why not? Well, because if this is enough, you don't need any tension here. Right? If this was enough to lift it, you don't need any tension. So how much power do you need? Nothing. Is the elevator moving? Yes. How much force do you need? None. So what do I need from my motor? None. Why? Because he's doing it. See it? See the idea? Now another question might be, to make it harder, is I could say, if you didn't have C, how much power do you need? If you did have C, how much power do you need? Right? So you do it both ways. And then you say, well, I need a bigger motor without the C. Understand? Does it make sense? Elevators are counterbalanced like this. Right? Why do you think they're counterbalanced?
To help water to...
Because you don't want a big heavy motor. You don't want a big heavy motor. So you counterbalance them to hold the kind of the static load. So all you're doing is lifting the fat people to get in there. Okay, so how am I going to find power out? I'm going to find the tension. I'm going to take 3 of those, and I'm going to multiply by the velocity. Okay? How do I find the tension? Free body diagram? Okay, so let's do a free body diagram. Okay, so I've got this elevator over here. I've got a weight down, mg. Let's see, I have 1, 2, 3 tensions. I'm going to call it T. There's 3 of them there. And then over here on the C, I've got another, I'm going to call it TC. Okay, let's see. Some forces vertically. TC plus 3T minus mg equals what?
0.
Why? Constant speed, 0. How many unknowns? How many unknowns? 2. How many equations? Okay, so something must be 0. Is it TC that's 0 or is it T that's 0? Okay, then what do? Yeah, there's more than one mass, right? So, you don't be surprised if you're not done until you do a free body of both masses. Oh, okay. So here's C. You got MC, G, and you've got TC. And let's see, and they give me the mass of C, thank goodness. So here I say, all right, TC minus MCG equals what? Why? Yeah, because if the elevator's going constant, then the C is coming down constant, right? How would you know if you weren't sure? You write the length of the rope. Okay, you write the length of the rope. Okay, so can you solve for T? Okay, so what's the power out? I already got that one. Give me the power out, right? You're looking at that one right there, yeah. I've already got that one. Yeah, it's the force and the velocity. Well, how many forces have I got? 3? 3 T's, and you know the number for T now, right? What's the speed? 4? So it's 12 T. Can you find the power in? Isn't it a piece of cake? Don't you want me to put 80% of the problems to be power and energy? Yeah, sorry, ain't gonna happen. Any questions? Bless you. Okay, I was gonna do some more energy problems.